So let me just give a brief introduction about myself. I have been with Big Data World for more than 10 years now, and about 7, 8 years in Richmond alone. I moved from Los Angeles for a project at Capital One, and I've been working in big data pretty much since then. Previously, I worked with Yahoo, Capital One, T-Mobile, and many other companies in big data world. Currently, I am a senior big data architect in Amazon AWS. And this talk is I am representing as a personal capacity. This is I'm not representing AWS over here. So whatever I quote, whatever I say, it is on my personal opinion. There is no AWS representation over here. Now, the goal of the hour, basically, I wanted to give you overview of the Glue service. Amazon has this managed service and provide you just enough information. I believe not many people are familiar with Glue. So I don't want to go in too much details. I want to make sure that at the end of this talk, you should be able to create a job, run a job, and know where to click for what thing. Um, so this is just to familiarize yourself and show you the way, the simplest path to develop an ETL tool. AWS Glue has been kind of like, based on Spark, since it's based on Spark engine, it is considered kind of like, code driven ETL process, which is very traditional in Spark based system. But in the past years and months, Glue service has evolved a lot, and there are a lot of good feature GUI related ETL functionalities that have been added, and I'm going to demonstrate those features. One of the feature, Glue Studio, released only last month. It was GA'd only last month, so I believe not many are familiar with it. Even if you have used Glue, you might not have used Glue Studio. So it would be good for everyone who has used Glue, who has not used Glue, or who have been using Glue, um, uh, but not kind of like use the Glue Studio. In the end, there will be a 200, 300 level talk, whereby I will share some of the tricks that I have learned, and some of the tricks that anybody can use and optimize their job while using Glue. So let us just understand the terminology that we are going to use over here, and I'm going to walk you through each of them. So in this is like, Glue is primarily used for ETL. It's a managed offering from AWS, just like many other AWS services. User do not need to worry about procuring server, setting up configuration, or worry about managing the systems. This is a managed offering for ETL purpose. So for ETL purpose, if you look in a traditional ETL format, in a traditional ETL, we have one source, we have one processing engine, and we have one output. And these things are driven by metadata, and the job needs to know what it is reading, the job needs to know what it is writing. There are alerting mechanism and fail recovery from failures. So all these things. So this, if we look at the Glue components, you can probably connect these dots to the experience that you have, and compare against these things. So in that way, you can easily assimilate these things. You can easily correlate with the ETL tool or the systems that you have worked with. And so I'm gonna, try to correlate these things. So, for example, let's start with the Glue catalog. So Glue catalog is based on the Hive Metastore. It's Hive Metastore compatible, similar functionalities. So it is similar to Hive. EMR can use it for Hive purpose. Athena has similar, query functionality that is using Glue catalog. Essentially, Glue catalog is a place where you can see database kind of, system. You have database, you have tables. Now, all these tables, all these databases are basically pointing to a source that is not necessarily stored in the catalog. Catalog doesn't store anything. It is simply, storing the metadata of the data sets it says. Now, the purpose of Glue catalog actually it is to discover schema. It is to provide information about the partition a table has. It is to evolve the schema if a new column is being added, if a new column being deleted, then the schema should be consistent to provide, uh, good, good output. I think somebody is waiting, Roman.
Okay, let me see.
I
Oh,
can
thank you.
also admit, yeah, yeah, that's
Actually,
okay.
yeah,
I
that's good.
admit, yeah, sure.
Hey, thank you. Hi, Glenn.
Thank you for joining. Yeah, so Glue Catalog is similar to, you can think of as a meta store in a data dictionary in a database world. It actually keeps a record and schema and the location, the partition and the schema change. All these things are actually tracked in a Glue Catalog. It is also supported by uh, Glue Crawler. So the crawler is I don't think there is any contemporary um, tool that is related to crawler. The job of the crawler is to basically crack open a file and read what it is, what the schema is, and based on it, um, it should create a table or partitions or update the glue catalog. So that the purpose of crawler is to read the metadata associated um, for a destination. The destination could be DynamoDB, it could be a database, it could be um, uh, S3 file. So anything that we point to, crawler will basically look at the source file and see what is the schema. So there is no human intervention needed to figure out the schema associated. Now, why this is useful and how it works. So, uh, crawler, let us say if we receive a new file in traditional enterprise world, somebody would provide the schema associated with it. Will be updated by some administration, database administrator or somebody who would maintain this, this table in some format, and that's a kind of like manual activity, even though the execution is automated, but there are manual process involved in figuring out the schema and how it should be stored and things like that. So crawler actually avoid that manual work, and it basically looks at the file, reads the schema, and updates in the catalog. If a new file comes and there are changes in the schema, it also updates the glue catalog correspondingly. So if a new column is added, a column will be added in the table. If a column is deleted, then based on the instruction that it has in the configuration, it will either delete the table, it will either delete the column from the table, or it will leave it as is based on our configuration settings. Because let us say, historical data could have the column, but new data might not have the column. So how do we want to see it? Do we want to completely ignore it, or do we want to leave it as is? So that's the purpose of crawler, and we are going to see it live, and we are going to see how it works. So I'm going to give you a practical experience of feeling, so that if you want to go, you can experience that on your own. Now, when we come to job, which is basically in the engine for any ETL programming, so there are primarily two types of jobs, you can say, in Glue. One is Spark based job. The Spark based job basically uses Spark syntax or um, engine that is associated with PySpark or Spark itself, Scala. The other one is the uh, Glue Python shell. So we can write our job in Python. If it is pure Python, then we can use the Glue Python shell to write it. If it is ETL based job and which requires distributed computation, which requires more functionality that is provided by Spark, some of the functionalities of joining, selecting particular columns, uh, deduping, all these things which might require in pure Python a code from the scratch. These things are already available in Spark libraries, so we can simply leverage those syntax and perform the ETL work. So we have two types of jobs that are that can be supported over here. The next comes the orchestration. Now, in any ETL world, there is it's not like that one job does all the things. Many a times, um, uh, ETL process is governed by or driven by many jobs. The jobs have particular sequence, and they are dependent on each other. Sometimes they take input from preceding job or pass parameter to the subsequent job. So the orchestration basically provide the sequencing. So Glue actually recently has added this workflow feature whereby one can go and add or remove job pretty much graphically. There is no coding needed. And all these things that I'm going to show is to demonstrate that how easy it is to write a job in Glue, even though the backend is very powerful, Spark or if you want to write in Python, but all these managed service are basically activated via few clicks or uh, via few GUI operations. So we can operate on the GUI in a very easy manner. Previously, the orchestration was done by Trigger. Trigger is kind of like your um, event sequence, whereby we can define that a completion of this job will trigger a subsequent job. So Trigger basically does that work, and it basically provide a sequencing for the whole operation. Next come the development. How do we develop a job? How do we debug a job? How do we modify a job? Every in most of the ETL based tools, there is their own IDE, mostly graphical, whereby somebody can go and modify the operations, update the operations, add functionality or remove functionalities. So Glue service also has similar um, areas whereby one can go and um, you know and develop a job. So dev endpoint is the place where you can request a place to um, see how to develop a job, uh, request a place to um, see how to run a job and whether or not the job is running fine, if there is any optimization needed. So dev endpoint is the component that actually provides uh, this feature. Next come the Glue Studio, and most of our discussion going forward will be focused on Glue Studio because earlier, maybe a few months ago, writing job in Glue was not very intuitive operation, um, and it becomes very difficult, or it was very difficult to write a job, a simple job, without writing a code. So thereby, these Glue Studio, which actually GA'd last month, improved these things a lot, and many of the operations can be done over GUI. So it doesn't require a lot of coding to begin with. Yes, if we want to improve the functionality, if you want to go beyond the basic, there are chances that you might have to code, but many of the operations, as we are going to see, can be performed without looking at without writing any code. And that's my goal. Like, I want um, every audience to be comfortable for writing a job after this discussion. The next come is the monitoring. Monitoring is important because many a times jobs are like, there are many jobs in an environment, and we need to be aware of their execution, whether or not they are performing well. Sometimes a summary report, mostly beginning of the day or end of the day, just to make sure that operations being performed correctly and there are no intervention needed, no manual intervention needed, like that way. So the monitoring of the jobs basically provide this information. There are two ways to monitor a glue job. One is via glue job, so glue studio. Glue studio has like, a single pane where we can see all the jobs in one place. This was a problem for many customers and users because it was very difficult to see the number of jobs and executed on a particular day, particular time frame, and how many of them been failed. And many have written their own utility based on the APIs, but there was no good front end. So Glue Studio has actually fulfilled that one. It's not perfect, but it is going over there, and it solves many of the issues. One can go and see how many jobs been, how jobs are performing, and if there is any attention needed. This can also be done via CloudWatch. CloudWatch is another AWS service which is primarily used for logging and monitoring, and it is integrated with pretty much every AWS service in the backend. And Glue is one of them too. And we can pretty much monitor every event that Glue jobs generate, and we can set up notifications as we need. Now I'm gonna take you to a live demo, and this is going forward till we come back on the interesting topics in optimization. This is gonna be, I'll walk you through and tell you where to click and what is the meaning of each click. So I believe everybody is familiar with AWS Console. AWS Console has this Glue service. It's a managed service. Now, if we go over here, um, we see all these topics that we have just discussed. And I'm going to give you just enough information. I'm trying not to give you too much information that can, that can that is not useful for most of the operations. So I'm giving you just enough information so that you are comfortable with writing a job and uh, and uh, uh, performing an ETL operation. Now, to start, actually, I have added files and S3 files. I believe everybody is familiar with S3. So in S3, I have uh, file. So I have a folder where I have stored some data that is associated with COVID data. So I have stored this in S3. If you are not familiar with S3, S3 is AWS service for storage, and this is one of the oldest service in AWS. So I'm expecting that everybody is familiar with it now. Um, this has ISO code, which is representing country, and other information related with hospitalization and other health related topics. for COVID. So this is one of the file, and what we are going to see is that in the file where we have this country code, which is also known as ISO code, is also represented in another file. The ISO file is actually a file where we have the mapping available. So the ISO file, for example, it says that ABW is for Albania, AF for Afghanistan, um, BZZ is for Algeria, like that way. So we have a mapping for each of the country code, and we have a source file that actually brings information and contains the information. So in like in many ETL operation, we enrich the data, right? So the source is sending country code. One of the ETL operation could be to join with the country code information and provide updates, make a file which contains both of the source and destinations. We are enriching the information, converting the country code to actual country, right? Now, let us see how we are going to do this one. Any questions so far? Okay, I'm assuming the question. Now, let us first see now when I have shown you these files. Essentially, we do not know what these file contains. I kind of like, if I need to discover a schema, I have to open the file and then tell you that what that file contains. Like, it's a manual effort. And if you have many files, maybe hundreds and thousands of files, maybe more, then it becomes very difficult to identify the schema associated, because some may have correct schema, some may not have correct schema, and all these things. Thereby, the glue crawler that comes in the picture, that is used to discover, that is going to discover a schema. Now, it's very simple. And again, try to follow me. Um, if we need to find out the schema of a file, let us say I'm giving this name. In most of the operations, you can just go with default. You do not need to provide any information, and you can pretty much um, uh, just provide information where it is mandatory. Rest of the things you can probably leave it as is, and there are no inputs needed. Now, what it is saying, it actually is in this one, we are creating a crawler by giving a crawler name. And when it is asking the source type, so our source could be S3, our source could be RDMS, our source could be DynamoDB also. So our source could be anything. Now here actually we are saying that data store is S3, and now we are saying that where the file is located. So my file is located in this folder, and these are partition, typical partition, date based partition, something like that one. So when we receive files, we have different partitions, and crawler will figure it out. Crawler will look at the pattern and say that, what, I am seeing 3 folders over here, and these look like partitions. I will call them as partitions. So let us see if it does it or not. So let's just go with all the defaults. And now, just like any other AWS services, service interact with service or resource, and it needs some authorization. So it needs a role. If you do not have a role created, if you do not know what to provide over here, feel free to choose create an IAM role, and it will create an IAM role which is suitable for your needs. So in if you stumble upon this one and you do not know what to choose, you can always choose, create an IAM rule. You can always delete it. It's not gonna uh, affect anything. At the same time, by security, this is allowing glue service to connect to S3 and read data. Glue service is a separate service. S3 is a separate area. When it is going to different area, it needs authorization, and authorization is interchangeably or internally exchanged via roles. So by providing a role, we are authorizing one service to access other resource because we have given them the permission. So thereby they can access the data. Now, when we need to run, we can run on demand or schedule. So if we know that our data would be coming, every hour, or if we want to, crawl this data at a particular schedule, we can do that. Now, let's create a new database. So let us just for demo purpose, let us say glue demo 2. And again, you do not need to provide any information that is not needed. Here, actually, for the time being, we can just leave the places as is, because all the tables that are going to be created will be created in a separate database, and we can always, ignore a prefix, but we can always do that. I'm not gonna provide you information over here because it's not needed for most of the operations, and you can just accept the default and finally finish. Once it is done, then we are going to see this in our list, and then we can run a crawler. Let me know if there is any question so far.
Hey, Vivek, one question. When the crawler does run, uh, does it scan the entire file to determine the data types?
That's a very good question. According to published AWS document, crawler does not look at the entire file. Let us say if there is a file that is 100 meg, then it will look at a first 5 megabytes of file and infer information from there, assuming that rest of the information will be consistent in a file. If there are 10,000 files, it will open all the 10,000 files and look a portion of it. So I think there is certain calculation published and may not be published. But yeah, it will not look, it will not read all the entire file. It will only look a sample of data, beginning of the file. Based on that, it will infer the schema.
Understood. Another question is around in this example, you showed a CSV file as an input.
Mhm.
If there are in real world, mostly these are compressed files, gzip, and other kind of compression going on. Would Glue crawler be able to scan those files?
Yes, please. Most of the files, JSON, Parquet, Avro, gzip, Snappy, most of the files that you see are actually, can be opened by crawler. So you can put pretty much any kind of file. Until it is a binary file, I never encountered any case where, Glue was not able to open because most of the common file formats are supported.
Okay, thanks.
Mhm. Now, when we have started this crawler, then we can see that uh, it has this runtime, and crawler is pretty fast actually because it doesn't read all the data. It is very fast in figuring out the schema, and thereby it actually updates this information as how many tables or how many tables being added or updated. Table added means when there is no table, because we have given a database, we have created a new database, and there is no table existing over here. That means it is going to say that I'm gonna add this table over here. If the table is already there and if the column being changed and things like that, then it will say table updated. Now if you see over here, yeah, we are seeing that the table is updated, though it is stopping. But once it is done, we can uh, uh, we can consider the table being added. Um, in any case, in future, if I'm just adding a 300 label information over here, if you run into any issues whereby you do not see expected output, feel free to look into the logs. It might provide you some information that you are not seeing in the file. So for example, if you put a file that is not opened by crawler, then you probably can see that unable to open file or some kind of exception over here that might give you information that crawler was not able to access the file. Now let's go back to the while it is running, I'm gonna actually add another crawler, and now since you are familiar, I will be a bit faster, and I'm gonna say ISO data discover, ISO dimension crawler. Everything is defaulted. Now I'm gonna point it to the location where our dimension data is stored. So I'm gonna say ISO mapping. That's where it is going to store. And crawler by default actually use the folder name that it has as the table name. So it is going to create the same name as the folder name. That kind of like, if we want to append something of if we want to prefix it something, then we can always add something over here that will kind of like, added in the table name. But otherwise by default, it will simply use uh, uh, the directory name and you folder name and use that as the table name. So this is going to be now while it is running. Let's go back to the table. In this one, now remember, if when I showed you first time, I wasn't sure what are the columns associated in that file, and what are the data schema and all these things. So um, it has more than 50 columns or 50 columns, and um, and the crawler has discovered that these columns are there, and these are the most likely data types associated. If column encounters two data type, then it will provide the better, or what you say, more accommodative data type as the final data type. So this is providing me that um, that these are the columns. Now, if we look at the partitions, crawler also discovers that, what, this table is probably partitioned, because partition is one of the best way to segregate your data. I believe that is pretty standard. If things are not partitioned, I'm sure that people uh, people have not done any kind of like data work, because partitioning is very essential in data storage, to isolate, to discover data by the respective segregation. So we can partition by date, partition by a specific field, or partition by particular key value. So partition is important, but crawler is discovered if there are multiple levels of partitions, then it will further actually segregate the partitions and say that these partitions being discovered. Now it has because we have used Hive style partition. Hive style partition means we are saying over here that the column name is the part date. This part date is not part of the file columns, but we are saying that the part date is the column of the partition. Then it actually has discovered it, and it actually has added it over here. So if we go over here, um, it actually has added the part date as the column, and it is defined as the string and partition. So all these things are discovered by crawler. Tomorrow a new partition is added, then the crawler will automatically add the partition in the existing table. We do not need to do anything else. Now, since we have completed our data discovery, we have two tables ready. Now let us see
how we can, perform some ETL work on this one. So here we have column, which is ISO code dim, that provides the ISO code, and this is the country name mapping. And in the other table, we have ISO code, which is the country acronym. So we are going to see how we are going to um, uh, perform a merge operation on these two fields. Now let us go to the Glue Studio, and let me go back to this one and show you. So Glue Studio, currently it's a new feature, so it is highlighted as a new feature. Now let us go over here and see how we are going to do this one. This is our canvas, and we have some independence. Let us start with a blank canvas, and let's go to the create one. You see, this is the job name. So let us say that merge ISO code, or any name that you would like to give. Now here actually we are going to say add. Now this is the node. The node is providing, basically pointing to certain operations. So here basically we are going to say read operation, and I'm going to say this is S3 source data. And here actually I'm saying that this is stored in S3, and I can say that this is stored in um, in glue demo 2 database. And when I say glue demo 2 database, it is going to point the tables associated. Here actually the table is created based on the folder name, so it's been created. We can ignore the partition for now. Just for simplicity, you can do it later, but now if you look at it, it has discovered that this source has this schema. We know that ISO code is coming from the source, and we have to merge it. So once we have added the node, we have to add another node, and this time it is a new node. It's again, let's say S3 dim source. Any questions so far? Okay. So here basically we are looking at the other source which has provided. It's kind of like dimension, and provided the dimension value first. So we are going to the database, and we are saying that ISO mapping. Now, if we look at the schema, it shows the schema that we discovered over there. Now we are going to see now over here another operation. Here actually we are going to say, I'm saying that it is join and node type. Here actually we have to go down, and now here we are going to use transform, and here in the transform we are going to say join. Now there are many operations that are possible in the transform, uh, and I will walk you through once we are done with the basic. Then I'll walk you through these things. So here basically we are saying that perform a join operation. Now the join operation, it is asking what are the parents. So I'm saying that dim source is already selected. Also select the source data. So here basically it is saying that it is connecting source data and dimension data. And in the transform, it is asking what type of join it is. So there are many types of join available. Inner join, left join, right join, left excluding join. That's a different type, but you can, based on the Venn diagram that it has, we can understand what type operation it could have. So I'm going to provide an inner join operation over here. If we have more conditions, then we can here basically we are saying that what are the join columns. So we are saying that ISO code dim should be equal to ISO code over here. So what we are doing, we are making an inner join, and the inner join condition will be based on ISO code dim and ISO code. That's pretty standard operation. I believe everybody is familiar with it. So I'm not gonna elaborate on that one. but we can see in the output, because it's inner join operation, it is actually combining everything uh, from both the tables, which is accepted. If we need to delete some columns, or if we have to do some other operations, we can always do that. But let us first put a destination. So let us put a destination, and here actually we can say S3 join output. And here I'm going to say that the destination is S3. And here we are going to say that, okay, when you add the location should be, no, it should be S3. So joined output as S3. There shouldn't be any data associated with it. Yeah, data target. So we are saying that the output will be S3, and my parent would be the join operation. So here now it is much more clearer, which says that we are merging two files. We are joining that over there, and we are storing that in a location. And the storing format here actually, we can pick any of the format that we want to store, JSON, CSV, Parquet, all these things. So um, we can choose the format that we want to, and then here we can say that where's my um, S3 location. So I can say S3 location is this one, and we can create uh, say we create another table. So if we say, so here actually let us say if I create another table over here, which is um, so what we are saying that join these two tables on particular column and save the output to this location. We can add a partition key and whatnot, but just for simplicity, I'm avoiding all these things and storing this data. What happens? Oh, I am wrong. Yeah. The job. Okay, let us see. Now here actually we are changing the number of DPs, and I'm going to walk you through this also, but let us just save it and run it. I think it might fail because I'm not seeing the role that I was hoping for, but we'll see. So now here the job is starting, and this is basically running a Spark based system in the background. It is all these things that we have done is actually appeared over here. So whatever we have done graphically that is represented over here is developed in code over here. And let us say if we change our code to Python to Scala, the code will also be changed to Scala over here. We can always take this code. Let's see, Python 3. Yeah, I think it is failed just because there was a role that I think somewhere it is lost, but let us just discover that part. That job was not saved. Merge ISO. I think this is the code. Um, yeah, there was some error. I think somehow it was not picking it up. Now let us run this one from here. When we create a glue job, by default has three runtimes available, retries available, and that is what happening. That it is continuously trying to run that one. Now let us see if that gets started. Okay, so the job is now running. I think there was some rule which I'm not sure how that got lost, but that was kind of like was providing this restriction because it doesn't have the permission needed. So all these things that we see in Blue Studio, actually it's coming from here. Earlier it was like that way. Blue Studio has kind of like simplified this part. So if we go to Blue Job Run, there's one running, and you run details. You can change the duration, and the job is should be succeeded. So we can see that the job is succeeded. Now succeeded means let us go back to S3. Let us see if it has created any um, data over here. So we created this this folder, and we can see that some file, some data is created. Now if we need to discover what is being created over here, we don't know the output. So let us do one thing. Let us go back to the crawler and ask crawler to create a table on this destination folder. So let's go back to the crawler. Now I'm gonna add another crawler, and I'm saying that glue demo check output, check new output. Here actually we are going to provide the path. So this is the new path, and so crawler is going to look at these files and then provide the schema. Now once that is done, now let us go back to the glue job that we had. So in the glue job, we had this, right? So what we have done, we actually merged two files and and provide this output. Now this is kind of like a standard operation. This is the way things are done. Now let us automate this part so that our execution should be somewhat automated, and we can execute all these things at will. So let us go back to the Glue Studio. Actually is not providing the workflow mechanism that is available elsewhere. So we have to wait until it is integrated. Otherwise, we have to go to the new place and create it over here. Now here we are going to create the orchestration that we are seeing. So in the job that what we were trying to achieve, we were seeing two files coming together. So at at one point of time when we feel like either scheduled or on demand, we are saying that run the job on this one, and once it is done, then you can update, you can run a crawler. So here actually we are going to create a new crawler. Demo. And in the workflow, now when we are going to the workflow, then that's the question. So we know that we are going to use a new. So we are saying that we want to either, now here is the thing, either we can say schedule, we say that okay, run at 5 o'clock in the morning or 9 o'clock in the morning. That's one of the option. When we say schedule, it will ask for the time when it needs to be run. On demand is like anytime when I click something. Event based is something when some event happen, some job event happen, or some event that is going to trigger it. In most operation, you can either schedule or go with on demand. So let us say execute first job, execute merge job. So this is my trigger, and now here actually we are going to say that when I execute this one, you have to run this job. So we can see that it basically is executing this job, and it is going to run this job. Now my second quest would be, once this job is completed, then run a crawler, and I'm saying that run crawler trigger. And this is automatically event based because it is dependent on the previous event. There is no the dependency. Now here actually I'm saying that run a crawler, and I'm saying that crawler run this one. So now things are pretty much streamlined over here. The GUI is not very good yet, but we can see. So what we are seeing that over here is that it's going to run the job first. Once the job is completed, then it is going to run the crawler. So it will automatically create new schema if it is available, and update the glue partition. Now, since we have created it on demand, so let us say we are going to say run. Now, when we are going to run, we are going to say history, and we are seeing that it has started, it is running. And if we go to that run history, then we know that this is currently running. We can see it will actually gradually change the color, and that color will show us that the work is completed or not. Any questions so far?
Yeah, I have a question. Sorry, Scott. So how do you handle errors and rollbacks within the workflow process?
That's a good question. Errors and rollbacks. So if the process is, if a job processing is idempotent, then these things could be handled by application code. Now, first is error. Now, if error happens, let us say here this job failed, or let us say there are 10 jobs associated and the job failed, then workflow actually will stop over there, because the fifth job in the sequence is not able to process particular day partition, and the job will fail because there was, let us say a code error, or there was something that code was not able to handle. So developer has deployed a new revision of the code, and the workflow has an option to resume it. So if something is failed, then it has an option to, if in the run actually, let's see, in the run, there is an option. So if it is failed, then it will stop over there. It will not process further data. And then let us say a new code base is deployed, then you can come here and resume it, and it will further process from the point it actually started.
Very
That's the
cool. Very
that's the
cool.
error. That's the error. Now, rollback. I would say that in most of the cases, you probably have to rerun the job. There is no rollback because once it is committed on a S3, it's committed. But if application is processing is really important, then obviously it will automatically rewrite or overwrite the data. So um, it might not make any changes. Now here,
Sure.
when I'm saying that the resume operation, we have to actually go a bit further in this one, and we have to augment the code such that they can pass the parameters. So let us say every day we are getting a new file or something like that, and the parameter is passing thing that process 2020 11 data. So we are passing this parameter in job, and jobs are communicating to other jobs that I have processed and I have placed this file, you have to pick it up from here and then process. So jobs are communicating between them through workflow properties, and thereby they know that what is the input and output for them. And yes, so what will happen that if a job failed, it will know that what was the input and output it should have, and the parameter will stay with the workflow. So when we come back to workflow and resume it, the workflow then rerun the job with those parameters. So even though let us say you are running it after 10 days, but it knows that it has to process 2020 11 data, then it will reprocess the data and knows that where to pick it up. The data structure should be like that, so that the partition or the file identifier is not overwritten and can process seamlessly. So it requires bit of data structure. At the same time, we have to augment the job to pass the parameters in between.
Yeah, that makes total sense. Yeah, you always got to plan for that rollback. No, I appreciate the feedback. That's great. It's great. Great stuff.
Sure. So this is the way. Actually, there are many things we can do. I'm just trying to give you something simple that you can start with, and then you can enhance these things. I don't want to give you too much details. There is this other dev endpoint. I just want to briefly touch this one. The dev endpoint is basically an area where one can go and start developing the job. Dev endpoint is supported by notebooks. So, the notebook is also a kind of like, IDE, particularly for programming, whereby one can go and write code and run interactively. So in the job, we are running the job, we are putting the job, and the job is executed kind of like independently, but in the here actually you can interactively run. You can run it, and you can test the output. You can further look it up and say that whether the output is reasonable or not, like that way. So this is the place where you can interactively test your code. In fact, you can copy paste the same code that you find it over here, and you can pretty much copy paste it over here, and then you can run it and modify it, because this is very basic code so far. If we need to augment and some of the functionality which might not have been provided by and glue code base, so thereby we have to augment, and that's the place where you can come and you can add these things. So dev endpoint, this is the place which provides you the which provides you the area to to augment your job, right? Now I'm gonna, in the interest of time, I'm gonna quickly go back to the area where I'm gonna show some of the tricks from the ground, so that you can always be cautious about it, and understand how to optimize and how to watch for these things. So job optimization. Glue has multiple worker types, and recently Glue released 2.0 about 2-3 months back. The Glue 2.0 comes with G1X by default, which has one DPU, one executor. When we say DPU meaning that this definition of 4 vCPU hardware which has this configuration. Similarly, for G2X, it has more power, but it reduces the number of executors. So if you are running a very memory intensive operation and running out of memory error, it's recommended to change your worker type and use that one. For most of the operations, G1X is good one, but if you run that one, then um, you should use the other worker type. um, Also should use the Spark UI matrix if you need to understand where the job is performing well or not performing well. I'll just briefly show you the matrix, also the UI, which can be accessed. So UI is available over here, I believe. Yeah, over here. So this is the Spark UI, which provides a lot of information of our job, how it is executing, how it is working, internal tasks and other things. So it goes pretty deep. It provides you pretty much every stage information for a job. So this is pretty detailed. I am not going over here, but I'm recommending that be familiar with it. There are a lot of tutorials you can find online to point particular area where one should be looking for job optimization. The next one, which is more valuable for everybody over here, um, and these are not documented things, but these are coming from my personal experience, which are going to be helpful for anybody who is going to use this one. So Glue actually uses its own construct called dynamic frame, and dynamic frame is similar to a data frame that Spark has, but both are two different things. Those are not same thing. But dynamic frame, like if you have a lot of small files, um, Spark based data frame would slow down just because it has too many files. And dynamic frame, there are options to group these small files. So use these options whenever, use the grouping option if you have a lot of small files. Similarly, the Spark UI, if you go to AWS document, there is a big page that says that how to install UI and whatnot. It can be bypassed. This is kind of like sort of hack, but it's also documented now, that whenever you create a dev endpoint, you can simply redirect your port to local port, and you can access the Spark UI at this address. It pretty much avoid all kind of installation that AWS documents ask for, and this can be directly accessed. Optimize between runtime and cost. So many a times we would see that um, uh, the runtime of a job is 10 minutes with 100 DPUs, and also 10 minutes with 50 DPUs. So whatever you get for lesser DPUs, always go for it and try to minimize the cost, because the more DPU means more money, and there's obviously more cost associated. So try to reduce that one and see if you are um, you can find a balance. Increasing the number of DPUs will increase the cost linearly, but it might not decrease the runtime, linearly. So you might find a balance, let us say, between the number of DPUs and the time associated with the number of minutes the job is running, and find a balance that is compatible with your needs, cost optimization, and SLAs. One important thing, actually, this is not heavily documented is that conversion between dynamic frame and data frame. I understand since many are new over here, are not familiar with dynamic frame and data frame, but just for recording purpose in future somebody comes, a dynamic frame and data frame can be exchanged in between and interchangeable for many of the operation, but each operation has a cost, and for heavy processing, this cost could be significant, and you could see data delay or the job delay just because of that one. Enable continuous logging that can give you a lot of information. Always add or try to add the source data file with the data. So let us say Spark has this function whereby we can add the file name as the column of the source file. So when we are looking for any kind of like abnormality or data type question, we can always go back to the particular file out of the 10,000 to 100,000 files that actually produce this data, and we can see if there was any error in the transformation or the raw source was like that one. So it's always helpful to add the source file in the data itself. And always try to reduce the number of partitions. Number of partitions or index could be useful in a database world, but if we increase the number of partitions, the lookup time increases, and thereby increases the SQL execution time. So try to reduce the number of partition as much as possible. And crawler is not needed if the schema is consistent. If the schema is consistent, not going to change, I would recommend start using Athena partition projection. It's a new feature recently been released. It will avoid the use of crawler. Try to use Glue 2.0. It's the latest version, and a lot of functionalities from 1.0. The startup time of 1.0 is 7 to 8 minutes, or sometimes 10 to 15 minutes. Glue 2.0 startup time is less than a minute, so it's very fast. Use Python shell job. Actually, it is pretty much similar to a Lambda job or the cost of Lambda, but Lambda has 15 minutes runtime. A group Python shell job has no runtime, and cost is pretty much the same. So if you have a long running job and if you want to run a Python shell job, feel free to migrate it over here. Dynamic frame reader is, let us say if you have a case, and I have encountered in one project whereby the files that we have received had inconsistent schema. So let us say there were 20 files received, all CSV file. First file, let us say, has 10 columns, all aligned. The other file had let us say 8 columns, and the columns are there, but they could be either switched or because if you are looking at the CSV, so not necessarily the additional 2 columns are at the end, so the missing 2 columns could be anywhere. And if you combine these CSV files, Spark actually would interpret them differently, and it will align them as first column to 8 column, and then rest of the 2 columns independently, whether or not of the same column. Dynamic frame is very good. So if a column is on the second place and it is coming in the end and the second file, it will combine pretty neatly, and any kind of like mismatches can be handled in the dynamic frame. And try to avoid writing too many S3 files, because if you have a big job and if you are writing too many S3 files, S3 has a limit of receiving not more than 3,000 put requests per second. So you might run into that one. So avoid small files and try to combine them. As I mentioned, reduce number of partitions as much as possible. Glue is meant for a managed service, and there are not a whole lot of knobs that are available for optimization. But yes, any configuration that you see in Spark could be used over here. You just need to put the conf parameter in a glue job. Also, always try to use the retry option that a glue job has. By default, it has no retry option, but I would recommend setting up to 2 to 3. And if a job is getting created by Glue Studio, by default, it has default to 3. These are three options. I have added, these links that can provide more information about these, parameters. Optimized actually will write your output faster because it will avoid the pass or the additional step that open source Spark uses. So that actually avoids, and it will write your Parquet data faster. Enable rename, it's a feature actually. It's kind of like bug in S3 because of the S3 eventual consistency problem. There are some partitions are not written properly. Using this flag can solve that issue. If you are providing any jar, Glue 2.0 actually has this option available, whereby we can tell the Glue to use the user provided jar first and not create a class level conflict in the jar. And these are some of the links that you might find useful. It has a lot of other information that you might find useful when you augment your job or use Glue extensively. Do let me know if there is any question now. Any questions?
Do you, how does uh, data like once you move the data from the source to target, incremental data, does the Glue handle incremental data updates?
Yes and no. Yes and no, because the objective of Glue is to move source data to target. It doesn't know how to provide these changes. Now, if it is a record level change, Glue wouldn't know what's inside, and the target has this data available or not. It's not the target. If it is S3, then we are writing file on top of file. It wouldn't basically at the record level, so it might not perform well. But yes, it can be done by instructing in the Glue job as how to merge this file. So for example, the output can be rewritten. Let us say if a file comes and updated file is there, then we have to rewrite the whole blob where all these records are saved. So theoretically it can be done. In practice, you will run into a lot of performance problem if it is a big data. If it is small data, 100, let us say 5-10 gig overall size, then yes, you can find numerous example blog or code where you can basically find the examples. It's a bit tricky because you are looking at the immutable place at S3 and try to update it, but you have to instruct in the code as how to handle this thing. If you are instructing in database, you have to perform a merge operation that also you have to code it. But so it can be done in Glue. If you want to really solve this problem systematically, then look at the component hoodie. It's associated with EMR. That actually essentially meant for this purpose for transactional data.
Okay, thank you.
Any other question? I believe there are no in the chat.
Hi, Vivek. This is Steve Rosenberg. I got hopefully a couple of real short questions. In my world, I get cursed with JSON strings within my Avro files, and also sometimes within my database columns. Will your crawler be able to pick out the schema from the JSON string within the Avro file?
Yeah, most likely. So what will happen? Most likely, again, it varies because of data, but and the crawler will, if it is consistent fixed format JSON, then it will crawler will determine that column as is what you say struct, and in that way you can potentially, so let us say if it is detected the column 1 as struct, then you can say column 1 dot name, column 1 dot address, column 1 dot last name, and get the fields from there. So crawler potentially can figure it out, but it varies basically because if the structure is not consistent, it might not be able to detect, but in most of the cases it might work fine.
Cool. People out there actually have consistent structures. How about that? I don't. Uh, can I provide my own schema rather than
Yes.
using the crawler provided?
Yeah. You can do that way. Crawler is crawler is meant for updating the schema as well as updating the partitions. Now, if you know what is your schema and it is gonna be consistent, then essentially there is no need to use crawler. But in crawler option, you can actually choose this one. So when we create a crawler, so you can always say crawler. And here actually you can say existing sorry, here actually it is yeah, it is. So existing catalog table. So if you are saying that, I have already created a table, and let us say this is my table, just add the partition as you deem fit, but don't update it. So it knows that this is the schema that it needs to infer or refer, and then it won't basically create its own schema until unless there are configuration option to say that, detect new column, and when you detect new column, do this, or when the column is deleted, do this. So that is configuration detection, but you can always dictate those things through the configuration.
Cool. Couple more.
Mhm.
Support for pipelines that branch and write to multiple syncs.
Support for pipelines and branches.
Well, if we have
Here
pipelines that
actually,
actually branch.
could you please explain a little bit more, because I know what is the answer, but I just want to make sure that I'm not going a different
Okay.
direction.
So I'm reading in a data set, doing a couple transformations, and then I'm going to split the result of that to a two or more branches. Each branch will do additional transformations and write their own output file.
Yeah, there are two ways to do that. Basically, either you can put that in the job itself. So, for example, last time when I mentioned over here, let's add another transformation. So let us say once we have added the join. So let us say you are saying that filter or segregation, and then you can say the data source is S3, and then think it will be our target. So it will be, mm, so if we are going to this one, right? So filter, okay. So here basically what we are saying that, okay, so this is my filter, my output. And here actually we are saying node type. So here actually we can say what we are trying to say. So let us say if you want to select 5 out of 10 fields, or you want to split fields, so you can potentially choose one of these options. And let us say let us say if I want to select from the join, so I'm saying that from the join operation, select only these columns, and so in that way these columns are stored, and these are going to go in the output. And here actually I can again redirect to S3 location. So yeah, that is one way of doing it. Like, if your data set is small and if you can make do in a job, you can put that in the application code, and the application code will be generated correspondingly to do this. You can also do in the workflow, like, you can create separate jobs. One would basically is just splitting the data, and the other job is picking up that data. So you can actually create that flow in the workflow, also in the workflow design and triggers, keeping in mind that workflow is suitable for most of our operation. But the moment you go in a very complex workflow, you will run into limitations of glue workflow, like it becomes a bit too complex. But it can be done. Not necessarily that's the solution, but yes, it can be done. We have two options over here.
I'm going to take a pause here in case anybody else has questions, but if nobody does, I still have a couple more.
Anyone else?
Hi, it's Roman. I think it's okay. I would like to maybe finish the session at around 6:45. That's
okay. Sure. So last question.
I think let's take the last question.
Okay, I'll throw it out there. Any plans for supporting Flink?
Oh, Flink. If you are actually going to Flink, if you have thought about Flink, then the Flink is already supported in Kinesis data stream. So, like, that's a different service. If you that's
Yeah,
already
but
supported over there.
any support for it within Glue?
In Glue, actually, both are, I would say both performing the same job. So, basically, if you are looking at that way, then Glue streaming is equivalent of that component. So, I think you are comparing maybe apple to apple in the functionality, but these are two company products basically. So supporting in the sense that both are performing the same operation. Kinesis also supports, I think Flink, right? What is that? I forgot the name. I think Kinesis Analytics has this supported. It's a recent addition over here. And yeah, see, Apache Flink is over here. So, both are internally performing streaming operation over here. And, both have similar nature. You can probably consume it over here, but Glue streaming, Apache Flink, both are, you are comparing the features of two components and could perform similar.
Yeah, I'm looking for the pretty pictures in the GUI for creating the workflow or the pipeline. So that's
Try Glue streaming. Actually, instead of Flink, you can use Glue streaming, and that could simply replace the Flink operation over there.
okay. Thank you, sir.
Thank you. I think Roman, up to you now.
Thank you. Let me unmute. Well, thank you so much, Vivek. I thought that was a great presentation, and thank you for everyone that asked a question. I will see the recording and post it online.
Sure. Thank you. I believe I was hoping that this will give some comfort to people who have not used Glue, and I try to try to aim for that one. If people start liking or start using Glue, I think that would be my success.
Awesome. And if you're not for Richmond, yeah, you can advertise this meetup for next time.
Yeah,
Thank
definitely.
you, Vivek.
And if there is any question, feel free to reach out to me for any Glue related question issues. You have my public email available. You can always reach out to me. Thank you.
Thank you. See you soon for real coffee, Vivek, maybe. Bye.
Thanks, guys. Bye.
Thank you, guys. Hey, Ford. Bye-bye. Bye, Ford.
Better late than never. Adios.
So much.
You were testing me, boss.
All right, guys. Thank you very much.
Yeah, bye, guys. I gotta go too. Bye-bye.
Bye-bye.